This is the Pre-AP Geometry Chapter 7 test review. We are going to skip over the constructions and get straight to the other problems. So number 3, we have a utility pole. Here's our utility pole. It runs to a point on the ground, and there's a cable going from there to there. This, around the ground, is 15 meters. We know the cable is 22 meters because it says so right here. And we would like to know how tall the utility pole is. We know there's a right angle there. So we know two sides of the right triangle. We're looking for the third side. So we have leg squared plus leg squared equals the hypotenuse squared. And by squared, I mean squared. So in my calculator, I find out that 15 squared equals 225, and that 22 squared is 484. Because you can leave your answers in decimals on this test, I'm going to do that here. It's 0.93, and 93 is closer to 9 than it is to 10. Number 4, we have lengths of a triangle. We know that if this triangle were a right triangle with legs 6 and 11, then the hypotenuse would be 6 squared plus 11 squared. 6 squared plus 11 squared, my calculator tells me, is 157. We would like to compare this to the 14 that would be there if this is a question mark right angle. So the 14 squared is 196. So the question is this side of 14 longer, shorter, or exactly the same as it would have to be a right triangle? And it is longer than it have to be a right triangle. So this is an obtuse triangle. Here we have a loading dock. We have the dock, we have the ramp. We know that the dock is 2 meters high, and we know that this is a 45-degree angle, which means this is an isosceles right triangle. So this is 2 meters, and this is going to be 2 squared of 2 meters. This is our simplest radical form answer. Make sure that you're paying attention on the test to how we would like the answers written. Most of the test you can round, but some of it you cannot. Number 6. This lovely problem. We know all the sides of the right triangle, or rather we have information about the sides of the right triangle. And when you know the sides and nothing else, this is going to be a Pythagorean theorem situation. So side squared plus side squared equals hypotenuse squared. Keep in mind that this is not just x squared plus 1 squared. If you FOIL this whole thing out, you get x squared plus 2x plus 1 plus x squared minus 12x plus 36 equals x squared plus 6x plus 9. That should be a plus sign, not a 19. Simplifying this, we get 2x squared minus 10x plus 37 equals x squared plus 6x plus 9. We have a quadratic equation because we have an x squared and an x squared. We're going to bring all the x squareds onto one side. In fact, we're going to bring everything onto one side. So we get x squared minus 16x plus 28 equals 0. We then factor this to get x minus 14, x minus 2. Remember, the factors that we are looking for are the numbers that when you add them up, you get negative 16, and when you multiply them out, you get positive 28. So we have x minus 14 equals 0, or x minus 2 equals 0, because the factors, when you multiply them together, equal 0. In this case, x equals 14. In this case, x equals 2. But we have a side x minus 6, and if x equals 2, then that side is negative 4. We can't have a negative side, so x is 14. Coordinates of P. In this problem, we have a circle that may or may not look like a circle on your screen. It does not on mine. But the radius of this circle is 1, because from here to here is 1, and from here to here is also 1, which means that the hypotenuse from the origin to P is also 1. So we're going to draw a line straight down. We have a right angle there with the axis, and we have what's essentially this triangle here, 30 degrees, 60 degrees, and a right angle there. We know the hypotenuse is 1, so this is 1/2, and this is 1/2 the square root of 3. If we go look back at our graph, this is our x-coordinate and this is our y-coordinate, because the x-coordinate is how far to the right of the origin something is, and the y-coordinate is how far up from the origin something is. If I can get this thing to work. Here we have a 30, 60, 90 triangle. Even though it doesn't look like it here, this is still the second biggest angle, so this is going to be the side that is normally something square root of 3 on it. Which means that this side, with the x, we're going to divide by the square root of 3 to get that. That's like dividing 12 by 3 and giving back the square root of 3 as change. To go from this x side to the y side, we are doubling it, which means we double the 8. And the square root of 3 is protected from the multiplication. Number 9, we have another 30, 60, 90 triangle. Let's sketch this thing out. So we have a 90-degree angle here, we have a 30-degree angle here, and we have a 60-degree angle here. The leg opposite the 30-degree is 2 meters. Which means that is the short leg of the triangle. To go to the long leg, you multiply by square root of 3. And to go from the short leg to the hypotenuse, you multiply by 2. Again, keep your answers in simplest radical form. Number 10, we have a 45, 45, 90 triangle, which means this is an isosceles triangle, which means that this is 10, and this is going to be 10 square root of 2. Same kind of problem. We have an isosceles triangle with a hypotenuse of 13 feet long. This is an isosceles right triangle, which means that this side that is 13 now is normally the side that has the square root of 3 involved with this. Sorry, this side is normally the side that has the square root of 2 involved with this. To go from this, we are going to divide the 13 by 2 and put back the square root of 2 as well, which means that this side is also 13 halves. Square root of 2. Cannot simplify the fraction, cannot simplify the root. So we have a 70-degree angle here. We are going to assume correctly that we are talking about parallel lines here. So we have either a 70-degree angle here or a 20-degree angle here, depending on how you would like to look at this. I'm going to go from the 20-degree angle. We have in this triangle the opposite side to the 20-degree angle and the adjacent side to the 20-degree angle. And we think, okay, so we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We have tangent because we have our opposite and our adjacent. So tangent of 20 degrees equals x over 8. To solve this, we multiply both sides by the 8 and type that into the calculator, which tells me that x is 2.91 units long. The units we were talking about are feet. We should also check to make sure that this side here with the x, because it's across from the smallest angle, is going to be smaller than the side we were given. In this case, considerably smaller because the 20 is much less than the 70. And we can believe that about 2.91 would be across from that 20-degree angle if 8 is across from the 70-degree angle. In right triangle ABC, tangent of A is square root of 3. So we know that that is not the right angle. It doesn't matter where the right angle is. What we know, though, is that because tangent equals the opposite over the adjacent, and this fraction is 3 over 1, that regardless of how big this triangle actually is, it simplifies to square root of 3 over 1. Which means that my triangle is horribly drawn. You might recognize this as a 30, 60, 90 triangle. And if you don't, you can always do the Pythagorean theorem to find the hypotenuse, which will have to be 2. So then we are looking for the cosine of A. Cosine is adjacent over the hypotenuse, the adjacent side to A being the 1, and the hypotenuse of this triangle being the 2. So 1/2 is the cosine of A. For this balloon problem, we're actually going to look at a couple different triangles because we can't deal with this obtuse triangle that has H as one of the sides. We're going to have to deal with the triangle looking at the bottom of the balloon separately from the triangle looking at the top of the balloon. Triangle looking at the bottom of the balloon has a 29-degree angle. Triangle looking at the top of the balloon has a 53-degree angle. And let me draw that out a little bit better for you so it actually looks like a 5. The difference between this height and this height is going to be h. We know we are 60 feet from the point underneath the balloon, so this is going to be 60 feet. This is also going to be 60 feet. So to find y, from the 29-degree angle, we have our opposite. We want to know our opposite. We know our adjacent. Same thing here. We want to know our opposite. We know our adjacent. So to find y, we are looking for the tangent of 29 degrees equals x. That's a y. Equals y over 60. When we multiply both sides by 60, my calculator tells me that that is 33.26 feet. And when we look at the bigger triangle, we have the tangent of 53 degrees equals x over 60. Again, multiplying 60 on both sides. And my calculator tells me that x then equals 79.62 feet. The difference then, because this was x, sorry, that was y, and this was x, subtracting the 2. Will give you approximately 46.36 feet. Number 15. A lot of people miss this question because they go too far. We are looking for the tangent of Q, which means all we are looking for is the tangent of this angle equals what over what. From Q, there's the opposite, the adjacent, and the hypotenuse. The tangent is the opposite over the adjacent, so this is going to be 4 over 3. That is it. I did not ask you to find the angle. I just wanted to know what the tangent of the angle was. And that's this right here. The second part of this question is we would like to know angle P. From angle P, 3 is now the opposite, 5 is still the hypotenuse, 4 is now the adjacent. So to find angle P, in this case, because we know every single side of this triangle, we are free to use sine, cosine, or tangent. It is up to you. I'm going to use sine because it is the first button on my calculator, which means I need to know the opposite, 3, and the hypotenuse, 5. To undo the sign, use the sine -1 of both sides of this equation, or the arc sine, depending on the calculator you're using. Sine -1 cancels out sine, and we're left with a measure of angle P on that side, and on the right side, my calculator tells me that the sine -1 of 3/5 equals 36.9 degrees approximately. Here we have our fly and our ant problem. The insects start here and need to get here. So for the ant to travel this, the ant will travel along the hypotenuse here and then up the side of the box, on the inside of the box. The fly will start here at this corner and just travel diagonally through the box in a straight line. So we have a right triangle in the middle of the box. We're going to start out by finding the ant's path. Let's first take a bird's eye view of the bottom of this rectangle. The diagonal of this bottom rectangle is the same as the first path that the ant has to travel. We know that this angle here, 21.8 degrees. We know this side here is 6 inches. So to find this blue line here for the first path of the ant, we need to use some trig. Let's call that x. In this triangle, we know the opposite. We're looking for the hypotenuse, which means that we are talking about sine. So the sine of 21.8 degrees equals the opposite, which is 6, over the hypotenuse, which is we don't know. We're going to multiply both sides of this equation by x, and we are going to divide both sides of this equation by the sine of 21.8. That looks like we're just switching them around, which is a shortcut you can use if you'd like. My calculator tells me that 6 divided by the sine of 21.8 is 16.156488, which, since we're going to be using this later on to find the fly's path, I do not want to round just yet. So this part of the path is about 16.16 plus the 4 inches from this side here, which means the ant's path is going to be about 20.16 inches long. The fly's path is the hypotenuse of the ant's path. I'm going to call that 16.16 while remembering that that is a rounded number. This is still 4. Because we know two sides of this right triangle, we're going to use Pythagorean theorem to find the third side. So leg squared plus leg squared equals the hypotenuse squared. I'm going to call that F for fly. And I'm going to keep in mind that this number here, I'm abbreviating, but when I type this into the calculator, I'm going to type the full number that I've written down there, or even better, don't let it out of my sight on the calculator to begin with, and I could just square the answer. I get F squared equals 277.03 approximately. Again, I'm leaving this in the calculator to get a more exact answer. So F equals 16.64, rounded to the nearest hundredths place. And this would be the fly's path. To find the angle something makes with an axis, first of all, we want to solve for y. So we're going to subtract 5x from both sides. So negative 6y equals negative 5x minus 18. Divide by negative 6. Y equals positive 5/6x plus 3. What I really care about in this problem is the direction that the line is going. The M for slope comes from the French word for angle, so it's not a surprise that when we're talking about the line that is going up 5 for every 6 that it goes over, that what we care about is this angle right here, which I'm going to call A because I'm being creative. We're using the right angles that are built into the grid already, and we notice that because we have the opposite and the adjacent to this angle, we are going to use tangent. So tangent of A equals 5/6. To undo the tangent, we are going to use the inverse tangent or arctangent, depending on your calculator, to both sides of this equation. On the left side, it cancels out the tangent, and on the right side, my calculator tells me the angle is about 39.8 degrees. Number 18 is very similar to the one with the balloon. We're going to want to look at this as two separate angles, or as two separate triangles. We have the big triangle, and we have the small triangle, because the trig that we know how to do can only be done in right triangles. So we're going to find the big triangle side and the small triangle side and subtract them from each other to get the difference between them, which is x. So looking at the big triangle, we know that's 250 centimeters. And this is 20 degrees. This is, let's call this A. In this triangle, 250 centimeters is opposite. A is, ironically, the adjacent, which is going to be tangent. So the tangent of 20 degrees equals 250 centimeters over the height, the altitude of the larger triangle. This is where it looks like we're switching the tangent 20 in the A, because we multiply both sides by A, and then divide by the tangent of 20. Plug that into the calculator. We get 686.869 centimeters. I'm always going to go a little bit further than I have to for my final answer while rounding during the problem because not doing so could mess up the rounding later on. To be extra creative, I'm going to call that one B. And in this triangle, we similarly have 250, 65-degree angle, and B there. We're still talking about the opposite and the adjacent, so we're still going to use tangent. Tangent of 65 degrees equals 250, the opposite, over B. Flip-flop those. Plug 250 divided by the tangent of 65 into your calculator. You get B is 116.577. Again, we're looking for the difference between them. So when you subtract 686.869 minus 116.577, you are left with X, the difference, which is 570.29 rounded to the nearest two decimal places. In the diagram, our 20-degree angle and our 65-degree angle are much closer to each other than they would be in real life. So it's not very surprising, looking at the numbers, that the difference between A and B is as big as it is, because the real angle B would be a much larger angle, and the real angle here for A, for the 20 degrees, would be a much smaller angle than it's shown in this particular diagram. This lovely problem, we've given you that separately to work out so that you're not confused by the entire diagram. Really, in order to find anything in this diagram, like we know the radius of this circle is 3, so CE, CB, and CD are all 3. But that's not much that we know about these right triangles in this part of the problem. So we need to find OC. We know that C is 5, 6, which means it is 5 over and 6 up from the origin. We're looking for the third side of a right triangle, which means we're using the Pythagorean theorem. So 5 squared plus 6 squared equals the diagonal OC squared. 5 squared plus 6 squared is 61. So the OC would be the square root of 61. I should probably draw that out a little bit nicer, especially for parts B and C. I'm sliding this triangle down and zooming in on it a little bit. Here's the information we know about this triangle so far. For part A, we're extending OC all the way to B, which is an extra 3. So for this, we're talking about square root of 61 plus 3. If you're typing that into your calculator, make sure to close the parentheses after the square root of 61, and you will get approximately 10.81, although square root of 61 plus 3 is the exact answer. If you would rather leave it like that, you may. For part B, we're looking for angle BOD, which is the same as angle COD, which is the same as that angle right there. For this angle, we know the opposite and we know the hypotenuse, which means we are going to use sine. So sine of the angle we don't know equals 3 over the square root of 61. To get rid of the sine, we're going to use the inverse sine, or arc sine, to both sides. And showing that work shows us that you understand the algebra behind this. In the calculator, I'm typing 3 divided by the square root of 61, close parentheses twice, and I get this angle as 22.6 degrees approximately. Because I've rounded that, I do not want to use that angle to find the missing side. I would rather use my exact answers that we figured out over here. Because this is symmetric down BO, and because these triangles are HL congruent, OE is the same as OD, so I'm just going to continue the work I started with this triangle to find OD. Again, we know two sides of a triangle. We're looking for the third side. OE and OD are the same. So OE squared plus 3 squared equals square root of 61 squared. Square root of 61 squared is just 61. So OE squared equals 52. OE, if you simplify the square root, will equal 2 square root of 13. Or if you'd rather plug this into your calculator, it's approximately equal to 7.21. We have a tree. The tree is 18 feet tall. It casts a shadow. The shadow of the tree is what we would like to know. And the angle of elevation of the sun, angle of elevation always coming from the horizontal, is 41 degrees. In this triangle from the 41, we know the opposite. We want to know the adjacent, which means we are looking at tangent. So tangent of 41 degrees equals the opposite, which is 18, over the adjacent, which is the shadow, x. Flip along the diagonal. Get 18 divided by the tangent of 41 degrees, which my calculator tells me is 20.71 feet, rounded to the nearest 100th foot. Again, we want to double check that the side across from 41 degrees, which is 18, is going to be the shorter side because this angle here is a 49-degree angle. So our answer, if we would like to ballpark check ourselves, should be bigger than 18. But not a lot bigger than 18 because the 49-degree angle is not a whole lot bigger than the 41-degree angle. In our archery contest, we have an archer who is 6 feet tall and apparently has posture problems. He shoots an arrow at an angle of elevation of 14 degrees. We have the tree that has the target on it. We are assuming a straight line to the target at a 14-degree angle. We know that this is 52 degrees. Sorry, we know that this is 52 feet. And we would like to know how high the target is from the ground. We'll get back to that in a second. Right now, all we can find is how high the target is from the height of the bow, which is 6 feet off the ground. So in this triangle, we know the adjacent, we want the opposite, we're going to use tangent. Tangent of 14 degrees equals the opposite, which is x over 52 feet. To solve this, multiply both sides by 52. On the right side, you're left with x. On the left side, your calculator tells you you have 12.965 feet. Keep in mind, though, that what we have found is just how high this is from the 6 feet we started with. So in order to get our answer for how high the target is off the ground, we need to add these two numbers to get our final height of approximately 18.97 feet. For 22, we are finding the measurement of angle B. Since we know all the sides, we can use whichever trig function we feel like using. Just for fun, because we haven't used it very often, let's use cosine. Here's our opposite, here's our adjacent, here's our hypotenuse. We're going to use the adjacent and the hypotenuse because we're doing cosine. So cosine of angle B equals 5 over 13. Cos negative 1, or arc cos, to both sides of the equation clears the cosine and leaves you on the right side 67.4-ish degrees. 23 is just like 22. I'm not going to do that with you. (24) and 25, again, similar kinds of problems. Here we are given the 35-degree angle. That's our opposite, that's our adjacent, and that's our hypotenuse. Knowing that we have our hypotenuse and wanting our adjacent, this time we have to use cosine. Cosine of 35 degrees equals x over 21. Multiply both sides by 21. And you have 17.20 with no unit because no unit was given to you. For number 25, we have our opposite, adjacent, hypotenuse. We know the opposite, we want the hypotenuse, so we're going to use sine. Sine of 28 degrees equals the opposite, which is 7, over the hypotenuse, which is x. We're going to multiply both sides by x and divide both sides by the sine of 28 degrees. Remembering in your head, in the back of your mind, that the sine of 28 degrees is an actual number, and it is not just 28. Calculator tells you that this is 14.91. So we have a slide making an angle with the ground. The angle is 34 degrees. It says the slide itself is 3.5 meters rather than the length on the ground, and we want to know how high the top of the slide is above the ground, which means that's going to be our x. We know our hypotenuse and we would like the opposite, so we're going to use sine of 34 degrees equals the x over 3.5. Multiply both sides by 3.5. And we get 1.96 meters above the ground. 27, we've done several problems like 27 so far. 28, a ladder leans against a building. Here's the building, here's the ladder. We know this makes a 58-degree angle with the ground. We know that the base of the ladder is 6 feet from the building, and we would like to know the height of the ladder. So the length of the ladder is right there, the building being the opposite side to the 58-degree angle. So we are given the adjacent. We would like to find the hypotenuse. We're going to use cosine of 58 degrees equals the adjacent over the hypotenuse. Cross multiply the x, divide by the 58, cosine of 58 degrees, sorry. And we get x is 11.32 feet. If you would like to check yourself, because a 58-degree angle is almost 60-degree angle, this should be pretty close to a 30, 60, 90 triangle. And if that angle were a 60-degree angle, and that were 6, this would be 12. But because it's a little bit less than a 60-degree angle, we would expect that the hypotenuse would be a little bit less than that 12. It won't help you on this test, but on a multiple choice test, it may be enough to get you the answer. So we have a man on top of a tower. He also has bad posture. That we know is 86 feet above the ground. We have a level plateau, which is nice. And there's a rock that is 500 feet from the base of the tower. We would like to know the angle of depression, which is this angle here, the angle that the man needs to look down to see the rock. The angle of depression is the same as the angle of elevation because alternate interior angles are congruent when lines, in this case, two horizontal lines, are parallel. Or you could find that angle and subtract from 90, but I would rather not do that. So from this angle x, we know the opposite, we know the adjacent, we're going to use tangent. Tangent of the angle we would like, it's 86, the opposite, divided by 500, which is the adjacent. And to get rid of the tan, we're going to tan -1, or arctan, both sides. This gives us x is approximately a 9.8 degree angle of depression if you're looking at the dude in the tower, or angle of elevation if you're looking from the perspective of the rock. Number 15. We have a pole supporting a circus tent. There are ropes that reach from the ground to the top of the pole, 45 feet from the ground. So this is going to be 45 feet, the top of the circus tent pole. We know that the ropes, that being the rope, makes a 50-degree angle with the ground. And we would like to know how much rope we need, not including tying. So we would like to know how long the rope is. We'll come back to the fact that we need 6 of them in a few minutes. from the 50 degrees, we would like to know the hypotenuse. We know the opposite, so we're going to use sine. Multiply both sides by x. Divide both sides by the sine of 50. One rope is 58.743. I'm not rounding this yet because I know I need to do more stuff with this rope. So the fact is that there's not just one rope, there are 6 ropes, all holding up this tent post. This is the length of one of them. So to find all of them, we're going to multiply this number by 6. So total rope minus what we would need for the actual tying is going to be approximately 252.46 feet. We have a building, we have the ground, there's treasure down here. We are starting to dig 850 feet away from the building. We need to figure out what angle we need to go to, by the time we get to the building, get 150 feet down. We know the opposite, we know the adjacent, we are missing the angle, so we are going to use tangent of that angle equaling 150 divided by 850. To get rid of the tangent, we're going to inverse tangent both sides of this equation, which gets rid of the tangent on this side and lets us know that we have a 10.0 degree angle to dig down to get to the treasure. And who says math isn't useful? 32. Operator of a lighthouse seals the sailboat. The lighthouse operator is 25 meters above the sea level. Don't worry about him. We won't let him fall. The angle of depression, which means from horizontal, is a 10-degree angle. And he sees a boat, which in this case is a Viking ship. How far is the boat from the base of the lighthouse? We're looking for that. Keep in mind that the angle of depression is the same as the angle of elevation. We could ask the exact same problem, saying the angle of elevation from the boat to see the dude in the lighthouse is 10 degrees. From this 10 degrees, we know the opposite. We would like to know the adjacent, so we are going to use tangents. Cross multiply the x, divide by tangent of 10 degrees. And that will tell you that the boat is 141.78 meters from the base of the lighthouse. Small airplane climbs at an altitude of 18 at an angle of 18 degrees with the ground. That's supposed to be an airplane. It doesn't really look like one. Please forgive me. What is the horizontal distance it has flown when it has reached an altitude of 800 meters? From the 18-degree angle, we know the opposite. We would like to know the adjacent. We have another tangent problem. Tangent of 18 degrees equals 800 divided by we would like to know. Cross multiply up the x, divide by the tangent of 18. Type that in the calculator. And you'll discover that he has flown 2,462.15 meters, or about 2.5 kilometers. Last problem. Superman takes off at a straight line. What angle did he take off? Which means he's not taking off directly vertical. He is taking off at an angle. And that is the angle we would like to know. That doesn't look like Superman, but let's pretend it does. The altitude he's at is 150 meters, which means we would like his path in meters. We don't have his path in meters. We have his path in time and speed, or rather, speed and time. So if we would like to know how far he's traveled, we want our answer in meters. We're going to have meters per second canceled out by multiplying by seconds. Which is 130 times 2.5, which means he has flown a total of 325 meters in that time. And now we have the sides of our triangle. Because we know the opposite and because we know the hypotenuse, we are going to use sine of we don't know equals 150 over 325. We're going to inverse sine of both sides. Type that expression into our calculator. And we are left with an angle of takeoff of approximately 27.5, 27.48 rounds up. And that is the review. I hope this was helpful, and good luck on your test.